Hello students, welcome to the first class of class 12 physics. Here we are going to take revision of vector algebra because before studying about electrostatics, you should know about vector algebra very well. You should understand vector algebra. Okay. Let's proceed then. What is a vector? Vector is a physical quantity. So before studying about vector, you should know what a physical quantity is. Okay. So what is a physical quantity? Those quantities which can be measured are called physical quantities, right? The quantities which can be measured, okay? SURED, that are called physical quantities, right? Physical quantities. Physical quantities are of two types, okay? You got that. Physical quantity types, right? One is scalar quantity, scalar quantity, the other one is vector quantity, right? Vector quantity, okay. So what is a scalar quantity? Those physical quantities are called scalar quantity which have only value, right? But no direction. Okay. Scalar quantity. Quantity are called scalar quantity which have only value and no direction. Associated associated with them, right? So they have no direction, right? For example, heat, kinetic energy, potential energy, power, heat. These are examples of scalar quantity. Okay. Next, what is a vector? What are the physical vector quantities? Vector quantity. Those quantities are called vector quantities which have values as well as direction, right? Which have value as well as direction. Those quantity are called vector vector quantities is which have value as well as direction. Okay. So for example, velocity has direction. Velocity has both value and direction. Velocity, force, acceleration, etc. So you got all these things, right? So here we are going to discuss mainly about vector quantity. Okay. So proceed to the next topic, vector representation. How is a vector represented? A vector is represented by an arrow sign and a letter. Okay. Like this. Okay. So we denote that vector by a letter, suppose A is V. Then if we want to denote the vectors by letters, we have to put arrow sign on the letters also. Okay. Suppose if you don't put arrow sign like this, they do not denote vector. They denote a value. Okay. Do not denote a vector. So arrow sign denotes the direction. Since vectors has direction, therefore this arrow sign on the top of the letter also denote the direction. That means overall it denotes a vector. Okay. This way a vector is presented. Okay. Now come to unit vector. What is unit vector? Unit vector has, from its name itself, we can know that it is a vector and it has direction. It has direction. But its value is 1 unit. Okay. Keep in mind. Value is always 1 unit. Suppose we are given one vector, position vector, the point P. Okay. This position vector is A. This point P. Suppose point is here. The displacement in the direction of x, y, z axis are respectively x, small y, and small z. Suppose given this vector x I cap plus y j cap plus z k cap. Look at this I cap, j cap, and k cap. Since it has cap sign, therefore they are the unit vectors. Unit vectors in which directions? I cap is in the direction of x-axis, I cap the direction of y-axis, and the I cap is in the direction of z-axis. Right. Now we are going to find out the unit vector in the direction of a vector. How can we find out the unit vector in the direction of a vector? First, we have to find out the value of a. How can we write the value of a? Simply take modulus, right, in this way. Modulus of a vector. Modulus sign is only the value. Okay. So a here. A means only the value of a vector. How can we find? Simply take the squares of the take the square root of the sum of the squares. Is x, y, and z values. X, y, z. Take squares of them and take sum of those squares values. Okay. And take square root. This gives the value of the vector a. Now we are going to find out the unit vector. How can you write unit vector? So this is the given vector. You can write this like in this way. A, write the value of a vector and multiply that value by the unit vector in the direction of a. This is the unit vector in the direction of a. This means this. This means this. So from here, how can you find out the unit vector? Simply write the given vector here and divide it by the value of the given vector. And this. So in this way you will get unit vector, the given vector, the direction of given vector. So we are going to take one example. Suppose we are given vector b. Suppose 2 I cap plus p j cap minus 1 k cap. Okay. So we have to find out the unit vector, the direction of b. So given vector is I cap plus p j. We can write this way also, 1 k cap plus into minus 1 into k. Now find out the value of b vector. How much? p square plus minus 1 square. Much it will be 4 plus 9 plus 1 will be root of 14. Now find out the unit vector, the direction of b. Can we write? Simply write the given vector and divide that given vector by its value. What is the given vector? Given vector is this: 2 I cap plus 3 j cap minus kk divide by value. Value is 14. Is 2 by 4 I cap p by 14 k cap j cap. J cap minus 1 by root of 14 k cap. This way you get unit vector, the direction of a given vector. So what I said one thing that the value of unit vector is always 1 unit. Okay. So let's check whether the value of this value this will give 1 unit. So what is the unit vector? We have got 2 by 14. That I cap I cap plus 3 by root of 14 j cap minus 1 by root of 14 k cap. Find out the value of this unit vector. Now simply take square root. 1 plus 3 plus minus 1 root of 14 root of 14 take square root. Much it will be 4 by 14 plus 9 by 14 plus 1 by 14. Okay. How much it will be? Take LCM. LCM will be 14. There you will get 4, 9 plus 1. So what will be the value? 14 by 14 आएगा 1 आएगा ना. So the value of unit vector is always 1 unit. Okay. In this way you have to find out the unit vector. Find out the unit vector in the direction of a given vector. First you have to find out the value of the given vector in this way and divide that value and divide the given vector by the value of it, and you'll get unit vector in the direction of the given vector. Okay. Now let's proceed to our next topic. Position vector. Same way I have denoted already. Okay. Also, I have already mentioned this. This is also one position vector. Also, we are given points in three-dimensional space. Okay. Our suppose dimensional space. Three-dimensional space. How many coordinates are there? Right. Suppose this is our x-axis. X-axis. This is y-axis. our z-axis. So this is our origin. And suppose we are given two points P and Q. This is P and this is how can we denote the position vectors from the origin and vectors of these points? Simply take elevation from the origin to those points. Okay. Okay. Yes. Give name those vectors. Suppose this is the small r1, small r, and coordinates of this are suppose y1, z1. This x2, y2, z2. This position vectors are written noted. Okay. What will be the position vector of point P? We want to write in expression, then write we express the r vector, one vector of point P. We have to write in this way: x1 I cap in the direction of this, y1 j cap the direction of axis, z1 k cap the direction of z-axis. This is the position vector of point P. Similarly, position vector of point Q will be like this: x2 I cap, y2 z k cap, z2. Instead of x, y, z, you can have any value. This way, the position vectors are denoted. Yeah. So already got this. Now come to angle between two vectors. Angle between. Suppose these vectors are in from the beginning, same beginning point. A and B. Vector A and B. From the same beginning point. This is, this direction, this direction. Here, the angle between this vector, this angle denotes the angle between these vectors. This is the angle between these vectors. Suppose they are not acting from the same origin point. Suppose position vectors P and Q. Suppose these are given P and Q vectors. This vector, this vectors. What will be the angle between these vectors? Still we can find out. Thus you is this. by dotted line. Is this that? Then angle, this angle is the angle between P and Q vectors. Understood? This will be the angle between these two vectors. This way also you can find angles. Okay. So now multiplication and division of vectors by scalars. How a vector is multiplied by a scalar or divided by a scalar. Simply you divide or multiply them. Okay. So this is a vector. This is a scalar quantity. This is vector quantity. If you want to multiply them, you just put in front of this in this way. Yeah? Multiplication in scalar and this way. This alpha can be any value. Any value हो सकता, it can be speed value, it can be any number, it can be constant also, any number, this way. And you can suppose beta is another scalar quantity, you can divide this also. Simply multiply and you simply put in front of a vector, you put the scalar quantity in front of the vector. We want to multiply, divide in this way. Okay. Now come to vector addition. There are two laws of adding vectors. Okay, one is triangle law, other is parallelogram law. Okay, in triangle law, what we do, two vectors are given. Suppose this vector is acting up to this point, another vector is acting in this direction from this point. This is a vector. Suppose this is vector A. This is vector B. The resultant vector of these two vectors will be from the beginning point of initial first vector to the point of end of the second vector, like this. Okay. This will be our resultant vector of two vectors, and R will be equal to A vector plus B vector. In my two vectors A, B and B are acting in this way, and resultant vector can be simply be found in this way. In them, and from where to where you have to draw this resultant vector from the initial point of first vector, the end point of the second vector. In mind, this vector, if we compare this vector system with this rotating system, simply just compare it. Suppose the these two vectors are rotating in the same direction or in the same going in the same direction, but our vector is simply, this is A vector, this is B vector, and R vector is opposite to them. R vector. This is technique. If two vectors are in the same direction, add them, they will be equal to that opposite vector. Here in the opposite vector is direction of R vector is opposite to the direction of uh, A and B. You can compare like that. Okay. Why I have mentioned about this technique? This is a technique. So we are going to apply this technique in an example. Okay, later I'll mention that later also. Simply notice the direction of these two vectors and the direction of this uh, resultant vector. This is like their A and B vectors are rotating in the same direction. This is rotating in the opposite direction. So at the two vectors which are in the same direction, not same direction, but they are like rotating in the same direction. Actually, their direction are in different direction. Okay, they are the direction of a vector is in this direction, and the direction of this B is in this. You can compare with this rotation. This is like from this to this. This is like this, rotating like this. Add these two similar, uh, add these two vectors in the same direction, staying in the same direction, rotating in the same direction, and put equal sign. In the opposite side, you put the vector rotating in the opposite side in this way. This is a technique. But main triangle law is simply this. This is a triangle law. Two vectors are in this way. Just draw the resultant vector in such a way that the origin of the beginning point of this vector is the beginning point of the first given vector. The end point of the resultant vector is the point of the second given vector. Okay. So this way is the triangle law. Now look at this. In this triangle law, the resultant vector is denoted in vector sign. Okay. Now in a parallelogram law, will get simply the value of the resultant vector will not uh, denote it in the form of vector. Okay. Suppose these two vectors are acting this way. Suppose this vector A, this vector B, they are making one angle in them. Angle is made by them. Okay. Angle between them is okay. So what will be the resultant vector? You just To find out the resultant vector, you just draw one parallelogram with these vectors. Okay, this way. So the value of this is equal to the value of this v vector, and the direction is in the same direction. You can assume like this, and then the resultant vector will be in this direction, this opposite angle. This is R vector. Resultant vector of these two vectors A and B will be R vector. Here in parallelogram law, we just we write only the value, the resultant vector. Only R. R means there is a value of the vector R. How can we get? We get this way. If the vectors are A and B, then we can get in this way. Take modulus of A, that means value of A only, and take square root square. Clearly this square plus twice A B cos theta means angle between the given vectors A and B. Take square root. This parallelogram, we get the value of the resultant vector this way. You can write this in this way also. A square B square plus twice A cos theta. There are no longer vectors, and okay, understood? Means in a triangle law, you got this. This is if this is A vector, this is B vector, so this is B vector. You got resultant vector in this way. Triangle method. So there also you get one angle in them. This is the angle. Yeah. There it is. This. Here simply we wrote R in a vector sign and added the vectors. Now if you take the root, this will be like A square plus B square plus A B cos theta. This parallelogram method. And take square root of R here. We'll get this. Understood? In the parallelogram method, you get only the value. In the in angle method, you get direction while adding two vectors. Direction of the resultant vector. Direction plus value also. Value is also there. While writing in vector sign, you simply add this in this way. Okay. Now suppose here resultant vector is making one angle with a vector A. That is alpha, suppose this is beta. And what will be, you can say that the resultant vector R is the direction of the direction of alpha degree making with the vector A. Okay. How do you get that angle? To find out that angle, you just find out 10 alpha from this figure. Press this and make this on a right angle triangle E. So this is E. So if you get right angle triangle, this angle and this angle are same. So this is given, that means this is given B. This is given means this is given. Okay. So from this figure, this is O P Q R. These points are O P Q R. This is A. So how do you get 10 alpha? 10 alpha is this bigger triangle, this bigger triangle. What do you get? Simply this by this. QE divided by OE. O is E means O E plus EE. QE. QE means what? This is beta, this is B vector, this is QE and this is beta. So from that triangle we get one relation, QE divided by QE or PQ, that is sin theta. QE means, QP means what? B vector. So B vector and this B vector to that side, that will be multiplied by sin theta. It will simply what? B sin theta. Okay. B vector. This will be simply what? OP means A. Okay. Sin theta. P means A vectors and PE means PE. PE. This will be P means what? P cos understood. In this way you get the value of 10 alpha. From that can get only alpha and send this 10 to that side. Then it will be 10 inverse of P alpha sin theta A plus E cos. Similarly, how much will be the beta? Beta will be opposite to that. Okay. That will be like A sin theta B plus A cos. Beta is what? Angle made by resultant vector with the given vector B. This way you can say in which direction will be the resultant vector. the given vectors. Okay, you got all this earlier. Now come to components of a vector. We can write a given vector, any given vector, in two components which are perpendicular to each other. Like this. So this is given a vector. Are given, yeah, a vector in two-dimensional space. Suppose, okay, in 2D, is not space, plane. Okay. Then this is our a vectors. Then we can split this given vectors into what? To two components which are perpendicular to each other. Suppose this is in xy. This vector is from origin of a xy frame. Okay, axis y axis means it has x axis and there is the axis of x axis. This is y axis. Origin of this vector is, that means it has started from this origin frame. Okay. Now we are going to write this a vector into two components. How can we write? Where we simply split this given vector in these two sides, in these two directions of axis and the y axis. How can we write that? Simply you draw one perpendicular and segment from this endpoint of the given vector to the axis. Simply this direction also simply in this way, perpendicular. Okay. So this will be y component of this given vector. Suppose I denote a y. This will be component of a vector component. Suppose I denote in this way. That means in the direction of x-axis its value will be ax. The direction of y-axis its value will be ay. Now how can we write this given vector into two components? We simply write this way, plus this much value will be in this in the direction of x-axis, and this much y value will be in the direction of y-axis, and then writing you will get a value which is equal to the given vector a. In this way we can split a given vector into its components. Similarly, if a given vector is in a three-dimensional space, then what we will get? Splitting it into three components, you can write in this way. The values, three directions. Okay, a, z in this. Understood? This, these, these, these directions are what? 90-degree. That means these components are 90-degree to each other. These components are 90-degree to each other. means ax clearly ay means vector ax is component of given vector. This way. Understood? We can write one given vector the in its components. Okay. Now come to next. Yeah. Here I have taken one example. Okay. Is given here. Split the force vector 6 Newton horizontally and vertically, which makes an angle of 60 degree with the horizontal line. Means if we denote the y-axis as vertical axis and y-axis as the horizontal axis, this way. This is our x-axis. This is our y-axis. This is our given force. Okay, how much is 6 Newton? It is making one angle 60 degree with the horizontal line, means axis. I split this force into two components, that means the direction of x and the direction of y. You draw one line segment. Okay, other one. Look at this. Suppose this is P. This is one right angle triangle. Okay. This means this. This means this. Take this. This will be, that means this is Fy. This will be Fx. So now this is a right angle triangle. From here, how can we get the value of Fy? How can we get? This is theta. Okay? This is a right angle triangle. Then Fy divided by F. It will be the relation. It will be sine 60 degree and 60 degree. So here we take only the value, little calculation at first. Okay. After writing the value, you can simply write in this way. So this will be f sine 60 degree. F sine 60 degree means how much? F is given, the value of F is 6 Newton into sine 60 degree means root 3 by 2. This will be how much? 3 by 3 into 3 Newton. Okay. Similarly, this by this cos theta. So f x by f cos डिग्री एफ एक्स कितना होगा एफ cos theta is 60 degree. How much? With the value of this fx, that will be 6 Newton into half, right? Will be 3 Newton. Okay. So in this way we can write the value of components. Like now this will be Fy will be 3 root 3 Newton. So Fy vector will be 3 root 3 Newton in the direction of Z, and Fx vector will be 3 Newton the direction of x-axis. I kept. So this and this are the components. This is in the vertical. This is vertical component. This is horizontal component. Is given force F. Okay. In this way, you can find out the components. You can split out the given vector into two components. Another example: a force F has magnitude of 20 Newton. Direction of F is at a 30 degree from negative axis towards positive y axis. Represent F in terms of I and Z. That means this is a two-dimensional time. Okay. Suppose this is the two-dimensional frame. A two-dimensional frame in two-dimensional plane. Okay. So this is negative axis. This is positive axis. This is positive y axis. Here you will get negative axis. Okay. Axis. I have not drawn. So what is given here? A force has a magnitude 20, and this force is making 30 degree with minus axis, negative x-axis, like this. So this is the force. This is force. This is making one 30 degree with negative x-axis. Okay. Force positive y-axis. This side, upside. So this will be positive y, negative y, not in this side. So this is towards y-axis. So represent F in terms of I cap and J cap. So for that we should know the value of the components. What will be the value of F in the y component and x component? For that we have to draw perpendicular line segment. For that we will get, suppose this is A, this is B, this is O. So that we will get one right angle triangle. Okay. This is what. From here you can get this y value. Fy. What will be the value? F sin theta. Keep in mind, while writing the y component, you will always get sin theta, sin relation. While writing the x component, you will get always relation. Okay. What is the value of f? Is 20 into sin 30 degree, right? And 30 degree. Write the value. Here is 20 Newton. I have written this here, 20 Newton. Okay. Will be the value? Sin 30 half, right? Will be 10 Newton. The direction of y. This. So, and this will be 20 into cos 30 degree. 20 into root 3 by 2. Then 10 root 3 Newton. So, let's represent f in terms of I and j. Yes. So, press f is the x component 10 root 3 Newton in the direction of x-axis. Plus, both have plus values, okay? So, this is in the negative direction. So, while denoting this vector sign, means I cap, you have to put this. This is in the negative x direction, okay? And another is plus, positive in the positive direction, positive y direction, that is 10 Newton, the axis. So, Newton, you have to write this Newton. In this way, you can represent one given vector to two components. Two components, okay? And split one given vector into components. Understand? All of you? Now come to another point, that is displacement vector. Yeah, earlier we learned about position vectors, right? So this time we are going to learn about displacement vector. And I mentioned one technique also earlier. So we are going to use that technique. Suppose this is three-dimensional space. Okay. This is our x-axis, this is our y-axis, this is our z-axis. Suppose position vectors are 2 points. Position vectors of 2 points are given in this way. Point P. This is point P. Point Q. Position vector of P is suppose R1, small r1, and position vector point Q is small r2. Suppose this way, okay. Position vector. So you have to denote this arrow sign. Now, what is the displacement between this point P and Q? Suppose this is your coordinates of this is 1, y1, z1. This is x2, y2, z2. And what will be the uh, position vectors, displacement vector between these points P and Q? Suppose I denote that displacement vector by a letter displacement from P to, okay, it is R. Now how can I write this displacement vector small r in terms of this position vectors? So here we are going to apply the technique. This is a triangle, right? This small r1 and r are in the same direction. Add them, and this is small r2 is in opposite direction. So this result will be like this, equal to this. These are in the same direction, add them, and realize that to the vector which is in the opposite direction. This way you can get. Now put small r in one side and this small r1 to other side. So this will be minus. So in this way you can write a displacement vector in terms of the position vectors, the two given points, this way. So this technique you have to use. What is the technique? You just add those vectors which are in the same, which are like rotating in the same direction. Equalize that to equalize and that to the vector is in the opposite direction. This way you can find out the resultant vector or the position vector, displacement vector between 2 points. Okay, in mind. Now come to product of two vectors. How two vectors are multiplied? We are going to study about that. Okay. So there are two procedures of multiplying vectors. Those are scalar product or dot product, the dot product or cross product. This scalar product, suppose two vectors are given in this way. They are making angle theta. Okay. Vectors A and B making one angle theta. Now the dot product is pressed is like this. To take two vectors, given vectors, and put one dot sign between them. Meaning of this is the dot product. The meaning of this is multiplication of normal multiplication the value of vector A, the value of vector B, the find cos relation between them. Cos relation between them. Relation of this theta. Okay. This is the dot product. And its name is other name is scalar product. Why scalar product? Because the whatever result will be there of this dot product, it will be a scalar value. This whole value is a scalar quantity, a vector. Here no direction is stated with it. Okay, the value. Okay, so this product is called dot product. Because the value is outcome is a scalar quantity. Understood? So now come to vector product of two given vectors. Okay. Suppose similarly previous one we are given a similar way we are given two vectors. Suppose vectors are given similar way. Okay. Making angle theta between them A and B. Oh, not 0. Origin. Okay. The origin they are acting in these directions. So how is the cross product expressed? You take those vectors this way and put one cross sign between them. This is the expression of cross product between two vectors, given vectors. Okay. And what will be the value? The outcome. The outcome will be like this: sin theta. Look at this. This is cross product or vector product. Yes, the result is two quantities given vectors. A vector and B vector is always a vector. The result is vector. So there will be one unit vector associated with this value. Okay. This unit vector. In which direction is the direction of this unit vector? Which side be the direction of this vector? Guess. Is the expression of cross product. So in which that will be the direction of this unit vector. The direction of this unit vector will be perpendicular to the plane where this and the vectors are there. Okay. So I wrote, I expressed this. So suppose this is a plane. This is a plane, two-dimensional. Just one plane. Suppose this is one plane. The vectors A and B are goes in this way. Okay, this is vector. This vector This is vector P. This is the angle between them. Then the unit vector will be in this direction. The direction is this perpendicular to the plane where the given vectors A and B are situated. Okay, means this unit vector n cap will be perpendicular to both vector B and vector A. Okay, understood. Direction of the unit vector getting after the cross product will be in the direction perpendicular to the plane where the vectors A and B are situated. Good. On one figure, these two vectors A and B are plane. Okay. The result of this vectors will be perpendicular. The direction of these two vector will be perpendicular to the plane. Have you denoted this whole value and the direction by vector C? And that in this way also. A and give this also. This sin theta n cap. That means n cap is in the direction of C. Or you can simply write AB sin theta n cap. Whole direction and the values is denoted by C here in this figure. Yes, this value AB sin theta, this direction, f direction. Okay. Yes, these values and cap direction. Understood? What is the product of two given vectors? Okay, let's get to another topic. Here I've shown some important related to cross product of two vectors. Okay, this if A and B vectors are given, then the result of A cross B will be opposite to the result of B cross A. Understood? माइनस साइन देने से इक्वल हो जाएगा. We put 1 minus and this will be equal. Otherwise A cos B not equal to B cross, because this is opposite to this. So if you put 1 minus sign, then it will be equal to each other. Understood? From the definition of cross product, we have found this. A cross B equal to AB sin theta and cap is opposite to B and A and vectors. Since A cross B equal to AB sin theta and cap, hence the cross product of two parallel or anti-parallel vectors A and B is 0 since theta is 0. What is parallel vector? The anti-parallel vectors is parallel vectors. What are parallel vectors? Suppose this in this way. They are in the same direction value, then they are called parallel vectors. Okay, and if they are parallel, they are opposite to each other. Opposite to each other. Suppose this. They are called antiparallel vectors. Look at this. What is the angle between this and this pair? 0. Here the angle between them is 0. Theta equal to 0. Since sin theta equal to 0, then whole expression will be 0. Hence the cross product of two parallel and or antiparallel vectors A and B 0, since theta is equal to 0. Understood? Similarly, look at this. Theta and theta is I cap and I cap. We take cross product between I cap and I cap, it will be 0. So this value will be equal to 0, 0 vector, that means null vector. This will be equal to 0 or a null vector will be equal to vector. Just look at this. If two vectors are in a plane, then we can write this, where n is an unit vector which is perpendicular to A and B vectors mentioned already. Will be opposite to or perpendicular to the given vectors A and B. Hence, this three-dimensional space, coordinate space, coordinate coordinate, we get this three-dimensional Cartesian coordinate. X, we get 3 x's. Okay. Why is that? In this direction, unit vector is I cap. In this direction, unit vector is j cap. In this direction, unit vector is k cap. Now, though these direction of these three vectors are perpendicular 90 degree, that means they are perpendicular to each other. So cross product will be I. You can follow this case. You have to follow the case of cross product. You have to follow this procedure. Suppose you have three vectors I, j and k. This is I cap, j cap. In this case, if you multiply I and j, this is the positive rotation. You can assume like this. This is positive rotation and this is negative rotation. I, j, this. In case of positive, after I you get j, after j you get k, after k you get I. Okay. So look at this, while multiplying I cross j, while taking cross product between I, j in this way, I, j, the result will be plus k, perpendicular to n j. Okay. But if you take opposite rotation, this way, j First say and I. This is positive rotation. You can, if you take cross product, then you will get minus. Similarly, if you take I cos k, this is negative rotation, right? I and k this way negative. Therefore, this will be minus. Just to look at this. This minus j cap and I cap is equal to positive. If you write j into j cross I cap, then it will not be equal to plus k cap. It will be minus. You put minus sign here. You put plus. Understood? So this is the meaning. Now what is this? If to if you get such an expression like this, a cross in bracket b plus c, then this multiplication will be like this: a cross b plus a cross c. Understood? And the last point: area of a parallelogram is shown in this figure. This parallelogram is in this way, right? There is something like this. In physical meaning, physically, a cross b denotes the area of a parallelogram. Suppose two vectors are given. Two vectors are acting in this way. This way. So if you take this is a vector, this is a b vector. You take a cross b. Physically, it gives us the area covered by these two vectors. This area. This area. This area. Okay. Physical meaning of A cross B means the area occupied by these given two vectors B. This area. The direction of this area will be perpendicular to this area. Degree. Understood? Will be A, B, sine theta and cap. A cross B. Physical meaning of this means yeah. Understood? It is written in point number 5. Now come to next topic, scalar triple product. That means this time we are going to multiply three vectors. Okay. There are two types of products. One is vector product and another is scalar product. First we are going to discuss scalar triple product. Okay. So how the triple product is taken? Suppose I take this. The meaning of this, these three are same. Okay. The value of them are equal. Suppose two, 3 vectors are given A, B, C. B, C. Okay. So at first we take cross product between any two of them. Okay. Suppose I have taken between B and C. This is a vector quantity because this is what? Vector product. So result of this product will be vector. Suppose this is P vector. Then with that P vector, with the result of this B cross C vector, we take dot product. Ultimately, how it will will you get? You get this, right? A dot P. This dot product. The value of this product will be what? A scalar quantity, right? Quantity. This is also vector. This is also vector. If we take the product, then ultimate result will be scalar quantity. Understood? Therefore, since the final result is a scalar quantity, hence it is called product is called scalar tuple product. Understood? I've shown with figure. Look at this. I have taken one example. This example. I have taken B cross C. B cross C means what? Area. This area. This area, right? And the direction of it will be in this direction, perpendicular to this area plane. Okay. Suppose A is in this. The result of this will be it is cross C. So B C sine theta means this. And with this value, this vector, we take the product. So there must be an angle between E and A. It will be that is denoted by phi here. Okay, I have denoted that angle by a letter phi. In this is the meaning of scalar triple product. Understood? This is the mathematical procedure, mathematical idea. But this physical meaning of this scalar triple product is the physical meaning of scalar triple product. Volume of a parallelogram bounded by vectors vector A, vector B, and vector C can be obtained by this scalar triple product. Okay, look at this. What is the uh, formula of sorry, this is parallelepiped. Okay, what is the formula of the volume of a parallelepiped? Volume area of any surface, area of any surface to multiplication into height of the parallelepiped, right? Height the parallelepiped. Okay. Now I have taken any area. Suppose I have taken B and C. Cross product. Then cross product will give us the area of this surface. This surface. Okay. The height from that surface. How much it be? This will be height. this will be high. How can we get that? Suppose this is our n vector of this cross product B cross C. In that direction, what is the value of this? Look, this is the height. This is the height. What will be the value of height? This is a vector. It will be h by a will be cos theta, right? From there, you find out height a cos theta. That is a cos theta. Now area is how much? E cross C. Dot product B cross C. Then somewhere here you have to take only the values. Okay. E cross C. So here also. What is the value? Here I have taken the value. Okay. This modulus will be the value a cos theta. Now in the vector form, how will it be? This will be B cos C. For any same for a dot B cross C. Put this also, you can put this also. Meaning is same. That means this scalar triple product gives us the volume of a parallelepiped. That is the physical meaning of scalar triple product. Understood? All of you? Next, proceed to our one question. Are these and these same? Any guess? 1, 2, 3, 4, 5. The answer is no. Okay. Why? Look at this. P cross C is a vector quantity. Suppose P vector. This is a vector. There is no two vectors. You can't write vectors in this way. There should be dot product sign or cross product sign between them. So here this whole expression is meaningless. This B cross C and the A cross B, these two are themselves not equal. And additionally, these whole expressions are meaningless. Therefore, they are not same. Or you can say that is meaningless expression. Understood? Now come to our final vector triple product. What is vector triple product? This time the result will be a vector. Understood? How, suppose, look at this. This vector triple product. That means no dot sign is there. All signs are signs. The meaning of this product is this. As you take a dot product between A and C, you will be out this bracket. Later, you will be out of this bracket and dot product between A and B will be taken. 1 minus sign will come here. Look at this. A dot C is a scalar quantity because that is dot C is a scalar product. Suppose that the result is alpha scalar quantity, then this will be alpha into B vector. Now, suppose A dot, this is also a scalar quantity. Suppose that is beta. See, this one vector and this is scalar. This is like multiplication of a vector by a scalar. This is also multiplication of a vector by a scalar. And this whole expression is what? Vector quantity. Similarly, this is also a vector quantity. And this bigger expression is, whole expression is a vector quantity. Therefore, this product is called dot product. Understood? If you don't understand anything, you can comment below there. You can comment below. Today we leave there. Bye.